everyone, it's Amy Osborne, Nature Bridge educator and PolarTREC educator. I'm at the Banks Peninsula near Christchurch, New Zealand. Been delayed a few days getting down to Antarctica, so instead I've been exploring this area. This is an area that was formed by volcanoes that started erupting 12 million years ago. I thought, what a perfect place for you to join me on a geological journey. Let's go. Welcome to the banks of the Avon River in Christchurch, New Zealand. This is where we're going to do a little bit of our geology basics. First, I want you to imagine that the Earth is an apple, and that the skin of the apple represents the Earth's crust. The Earth's crust is all the land on Earth, both land we can see and land that's covered by the ocean. And it covers our entire globe. The crust is actually broken up into different sections, and we call those sections plates. Sometimes they're continental plates, sometimes they're oceanic plates. If we peeled the skin of the apple back, underneath we would find, well, if it were the Earth, we'd find the mantle. And the mantle is a layer of molten rock, and that rock is in constant motion. To move forward, we need to understand that there is the theory of plate tectonics. And plate tectonics is a theory that's been put forth that says that the Earth's crust is in constant motion, and it explains the movement of the Earth in a way that things have formed. There's a hypothesis that it's the convection currents in the mantle, which means the way that the rock is moving, the molten rock, that is the reason that the plates on the Earth are moving. So how do these plates move? Well, there's some different ways that they can move. They can converge, which means that the plates might come together. They can diverge, which means they come apart. And they might transform, which means they rub up against each other. When they converge, a couple things that can happen. There can be uplift, which creates some mountains, and there can also be subduction, which also can create mountains and volcanoes. I love to use a sweet treat to demonstrate this a little bit more. So if you have a cream-filled cookie like I do, go ahead and get it now. If you don't have one, well, maybe pause this and go find one. It's pretty fun to use this to learn more. Step 1, take your cream-filled cookie apart. You might wind up with cream on one side, cream on both sides. It doesn't really matter for what we're doing. Now remember, these are actually going to represent the Earth's plates. Remember, that's part of the Earth's crust, and it's the pieces that are broken apart. The plates can converge, which means come together. They can diverge, which means spread apart, and they can transform, which means rub against each other. This rubbing creates earthquakes. So if you live in an area like I do, when the boundaries rub together, that's called transforming, and earthquakes are created. So remember, they can converge, and when they converge, that can create uplift, and the uplift can make mountains. When they converge, they can also subduct. Subduction happens when two plates are of different densities. That often means an oceanic plate has run into a continental plate. And the oceanic plate is more dense, so it will actually subduct or go under the continental plate. When this happens, a few things can occur. If you live where I live in the Martin Headlands, some of the rock that was piled up on that plate gets rubbed off and forms these sort of wavy layers. And it can also form some hills and mountains. With the subducting plate that has now gone under, this rock that was on the plate is exposed to a lot of heat and pressure, and it can liquefy again and turn into magma. And as the magma builds up, well, then that's how our volcanoes form. Well, thanks for joining me, and if you have your sweet treat, you can go ahead and reward yourself now. Let's talk more about New Zealand and Antarctica and the way they were formed.